Learning objectives. At the end of this topic, you will be able to explain the laws of reflections, discuss about regular and diffused reflection, explore how visually challenged persons read or write and empathize with them, understand the usage of 2 or more mirrors to form multiple images, understand the structure and function of a human eye, understand the need or importance of taking care of eyes. Introduction. The world is largely known through the senses. The sense of sight is one of the most important senses. Through it we see mountains, rivers, trees, plants, chairs, people, and so many other things around us. We also see clouds, rainbows, and birds flying in the sky. At night we see the moon and the stars. We're able to see the words and sentences printed on this page. How is seeing made possible?
We can see it through our eyes.
Right. What about the phenomenon governing it?
I don't know.
This is made possible by means of reflection. Let me explain more about this in this chapter. What makes things visible? We know that we can see various objects through our eyes, but we cannot see objects in the dark. It means that eyes alone cannot see any object. It is only when light from an object enters our eyes that we see the object. The light may have been emitted by the object or may have been reflected by it. We have learned that a polished or a shiny surface can act as a mirror. A mirror changes the direction of light that falls on it. Laws of reflection. Let's perform a small activity to illustrate about the laws of reflection. Fix a white sheet of paper on a drawing board or a table. Take a comb and close all its openings except the one in the middle. You can use a strip of black paper for this purpose. Hold the comb perpendicular to the sheet of paper. Throw light from a torch through the opening of the comb from one side. With slight adjustment of the torch and the comb, you will see a ray of light along the paper on the other side of the comb. Keep the comb and the torch steady. Place a strip of plain mirror in the path of the light ray. We can observe that after striking the mirror, the ray of light is reflected in another direction. The light ray which strikes any surface is called the incident ray. The ray that comes back from the surface after reflection is known as the reflected ray. Now draw lines showing the position of the plain mirror, the incident ray, and the reflected ray on the paper. Remove the mirror and the comb. Draw a line making an angle of 90 degrees to the line representing the mirror at the point where the incident ray strikes the mirror. This line is known as normal to the reflecting surface at that point. The angle between the normal and the incident ray is called the angle of incidence. Angle I. The angle between the normal and the reflected ray is known as the angle of reflection, angle R. If the experiment is carried out carefully, it's seen that the angle of incidence is always equal to the angle of reflection. This is known as the law of reflection. Laws of reflection. When the whole sheet of paper is spread on the table, it represents one plane. The incident ray, the normal at the point of incidence, and the reflected ray are all in this plane. When you bend the paper, you create a plane different from the plane in which the incident ray and the normal lie. Then you do not see the reflected ray. It indicates that the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. This is another law of reflection. We may recall that in an image formed by a mirror, the left of the object appears on the right and the right appears on the left. This is known as lateral inversion. Regular and diffused reflection. When all the parallel rays reflected from a plane surface are not parallel, the reflection is known as diffused or irregular reflection. Remember that the diffused reflection is not due to the failure of the laws of reflection. It's caused by the irregularities in the reflecting surface, like that of a cardboard. On the other hand, reflection from a smooth surface, like that of a mirror, is called regular reflection. Images are formed by regular reflection. Reflected light can be reflected again. Images are formed by regular reflection. When you visit a hairdresser, he makes you sit in front of a mirror. After your haircut is complete, he or she places a mirror at your back to show you how the hair has been cut. This is made possible by means of periscope. The periscope makes use of two plane mirrors. Periscopes are used by soldiers in bunkers to see things outside. Multiple images. We're aware that a plane mirror forms only a single image of an object. Let us see what happens if two plane mirrors in combination are used with the help of an activity. Take two plane mirrors. Set them at right angles to each other with the edges touching. To hinge them, you can use adhesive tape. Place a coin in between the mirrors. Now hinge the mirrors using the adhesive tape at different angles, say 45 degrees, 60 degrees, 120 degrees, 180 degrees, etc. Place some object, say a candle, in between them. Note down the number of images of the object in each case. Finally, set the two mirrors parallel to each other. Find out how many images of a candle placed between them are formed. The idea of number of images formed by mirrors placed at an angle to one another is used in a kaleidoscope to make numerous beautiful patterns. To make a kaleidoscope, get 3 rectangular mirror strips about 15 centimeters long and 4 centimeters wide each. Join them together to form a prism. Fix them in a circular cardboard tube or tube of a thick chart paper. Make sure that the tube is slightly longer than the mirror strips. Close one end of the tube by a cardboard disc having a hole in the center through which you can see. To make the disc durable, paste a piece of transparent plastic sheet under the cardboard disc. At the other end, touching the mirrors, fix a circular plain glass plate. Place on this glass plate several small pieces of colored glass. Broken pieces of colored bangles can be used. Close this end of the tube by a ground glass plate. Allow enough space for the color pieces to move around. Designers of wallpapers and fabrics and artists use kaleidoscopes to get ideas for new patterns. What is inside our eyes? We see things only when light coming from them enters our eyes. Eye is one of our most important sense organs. It's therefore important to understand its structure and working. The eye has a roughly spherical shape. Outer coat of the eye is white. It is tough so that it can protect the interior of the eye from accidents. Eye has transparent front part called the cornea. Behind the cornea, we find a dark muscular structure called the iris. In the iris, there is a small opening called the pupil. The size of the pupil is controlled by the iris. The iris is the part of the eye which gives it its distinctive color. When we say that a person has green eyes, we refer actually to the color of the iris. The iris controls the amount of light entering into the eye. The lens focuses light on the back of the eye on a layer called the retina. Retina contains several nerve cells. Sensations felt by the nerve cells are then transmitted to the brain through the optic nerve. There are two kinds of cells. 1. Cones, which are sensitive to bright light, and 2. Rods, which are sensitive to dim light. Besides, cones sense color. At the junction of the optic nerve and the retina, there are no sensory cells, so no vision is possible at that spot. This is called the blind spot. The impression of an image does not vanish immediately from the retina. It persists there for about 1/16th of a second. So if still images of a moving object are flashed on the eye at a rate faster than 16 per second, then the eye perceives this object as moving. What is inside our eyes? Nature has provided eyes with eyelids to protect from any object entering the eye. Eyelids also shut out light when not required. Eye is such a wonderful instrument that it can see distant objects as well as near objects clearly. The minimum distance at which eye can see objects distinctly varies with age. The most comfortable distance at which one can read with a normal eye is about 25 centimeters. Some persons can see near objects clearly, but cannot see distant objects so clearly. On the other hand, some persons cannot see near objects clearly, but they can see distant objects quite clearly. With suitable corrective lenses, these defects of the eye can be corrected. Sometimes, particularly in old age, eyesight becomes foggy. It's due to the eye lens becoming cloudy. When it happens, persons are said to have cataract. There is a loss of vision, sometimes extremely severe. It is possible to treat this defect. The opaque lens is removed and a new artificial lens is inserted. Care of eyes. It is necessary that you take proper care of your eyes. If there is any problem, you should go to an eye specialist. Have a regular checkup. If advised, use suitable spectacles. Too little or too much light is bad for the eyes. Insufficient light causes eye strain and headaches. Too much light, like that of the sun, a powerful lamp, or a laser torch, can injure the retina. Do not look at the sun or a powerful light directly. Never rub your eyes. If particles of dust go into your eyes, wash your eyes with clean water. If there is no improvement, go to a doctor. Wash your eyes frequently with clean water. Always read at the normal distance for vision. Do not read by bringing your book too close to your eyes or keeping it too far. We know that if food is deficient in some components, eye may also suffer. Lack of vitamin A in foodstuff is responsible for many eye troubles. Most common amongst them is night blindness. One should therefore include in the diet components which have vitamin A. Raw carrots, broccoli, and green vegetables such as spinach and cod liver oil are rich in vitamin A. Eggs, milk, curd, cheese, butter, and fruits such as papaya and mango are also rich in vitamin A. Visually challenged persons can read and write. Some persons, including children, can be visually handicapped. They have very limited vision to see things. Some persons cannot see at all since birth. Some persons may lose their eyesight because of a disease. Such persons try to identify things by touching and listening to voices more carefully. They develop their other senses more sharply. However, additional resources can enable them to develop their capabilities further. What is a Braille system? The most popular resource for visually challenged persons is known as Braille. Visually challenged people learn the Braille system by beginning with letters, then special characters and letter combinations. Methods depend upon recognition by touch. Each character has to be memorized. Braille text can be produced by hand or by machine. Typewriter-like devices and printing machines have now been developed. Summary. Let's summarize the topic. Eyes help us to see various objects around. Law of reflection states, angle of incidence is always equal to the angle of reflection. The incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. Eyelids protect from any object entering the eye and shut out light when not required.